So in this video I'm just going to introduce the idea of scientific notation. It's also called standard form. So I've just copied this from the textbook. It's exercise 2.5 or section 2.5. So scientists often need to represent very large numbers or very small numbers. So they mention that here, very large numbers. And to make it easier to manage to calculate those numbers, scientists normally write a very large or very small number using scientific notation. So scientific notation has two parts. And here's an example. We got 5.316. Let's get my pen. 5.316 times 10 squared. Now, you should know 10 squared is 100. And the first part of number, this is the convention. For scientific notation, the number must be the first part of the number must always be a number between 1 and 10. No greater than 10 actually, it can't equal 10. It's got to be 1 up to but less than 10. And in the second part, a power of 10. So this actual number here, we can actually write it out. So 5.316 times 10 squared, well, that's just 10 squared is just 100. So when you multiply this by 100, the decimal point will move 2 places to the right, so the actual number will be just the number 531.6. So in this form we just say that's just normal decimal form, and up here this is using scientific notation. So let's look at an example that we're going to convert from scientific notation. They actually tell you up here that Jupiter is approximately the distance of 778 547 200 kilometers. So Jupiter's that distance from the Sun, so that's 778,547,200 kilometers. So to write this in scientific notation, essentially what I'm going to do, we don't want to do this normally. We need to move the decimal place. So initially, let's write the number out again. This number didn't have a decimal place, so I'll put 1 in. There it is, there's 0. So I'm going to move this decimal place by dividing by 10. And every time you divide by 10, you then have to multiply back by 10. So I move it 1 place, so that means I'm going to multiply by 10. 2, 3, 4, 5, 6, a bit rough there, 7, 8. And I stop when the decimal point ends up in between the 2 sevens, because that's 7.78. So that's a number less than 10. So let's write down the actual answer. In scientific notation, we write this as 7.78. And then we times it by 1, 2, 3, 4, 5, 6, 7, 8. 10 to the power of 8. If you get your calculator out and multiply that back by 7.78 times 10 to the 8th, you would get back to the original number. I might try that. Here's my calculator, so I'll show you. Here's a calculator. If I type in 7 point, I'm just going to use my keyboard to type the number in, times, you can find your power key. This key here, you can type 10 and then you press the power key to enter the power, and I put 8 and I press enter, and you'll see, sorry, actually I've made a mistake, haven't I? I've dropped some numbers there. I didn't mean to do that. Silly me. Let me fix that up. Yeah, the other digits I left out. Let me go back and put them back in. So there should be 5, 472 times 10 to the power of 8. Okay, let's go back and try that again with the calculator. Sorry about that. So I'll put 7.785472, and then I'm going to go times 10, base 10 to the power of 8. Press enter. And you'll see that's identical. You see there's 2 zeros at the end here, which matches the original number. So here we've gone from, and I'll just put that in kilometres because that was the units. I won't rewrite the final answer, the original number. So just keep in mind, up here, this is decimal form, and down here, this is scientific or standard form. And that's pretty much it. Let's do a different example. What about something that's smaller? Just see if I find a line tool. I think the size of an atom is something like 0. Talk about nanometers, right? So that's roughly about the size of an atom, I think. So that's about, I think that's about 1 billionth of a meter, I think. I think the units might be meters. I may be wrong. So it's 1 billionth of a meter. And so that's so small we can't even see that for our vision. So this time what we're going to do is we're going to multiply by 10 to move the decimal point. And we're going to move the decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9. So you get a decimal point there. So we end up with 1.0 times by 10. We need now to divide by to actually get this number back to the original number. Actually, I'll just do this so it makes hopefully a little bit more sense. Essentially, we have to divide by 1 billion. So to get in scientific notation, essentially we have 1 times 1 on 1 billion. And there's actually a way we can write this. This is 1 times 1 billion is actually 10 to the power of 9. See, 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. And normally when you have 1 over 10 to the power of 9, if you remember the first video, you can actually write that with a negative power. You'd write that as 1 times 10 to the power of negative 9. So there's an example where we've taken a number that's less than 1 and we've written it using scientific notation.